Dear students, in the last video we studied the electric field due to the line charge distribution. In this video we are going to see the electric field due to the surface charge distribution. For that purpose we have to consider a one surface, right? So see, this is the xy coordinate system. First of all, x axis, y axis, origin, and consider a surface. Suppose this is a surface, right? Surface means what? We can say that a page of notebook, of thin wall, we can consider as a surface. So this is the surface, and divide this surface into very small area, right? So consider one of the small area. What is our target? Right? What is our target? To find electric field at a point P. This is our aim, to find electric field at point P due to the surface charge distributions. Means what? The charges are uniformly distributed on the surface of this surface, right? So for that purpose we are going to divide this surface into small area, right, and consider one of the small area. So this is the one of the small area. So here this this is r vector, this is small r vector is the position vector of the small area, right? The r dash is the distance of a point P from the area. Again we can say that is r dash cap is a unit vector, r dash vector is a position, it is a vector from area to point P, and here capital R vector is a position vector of point P. So this is the information regarding the diagram, and we are writing the information. See, what is R vector? We will write R vector is the position vector of a small area element. Last time we considered length, right? Length, area element, line element we have considered last time. Now we will consider area element, R vector, right? See, what is capital R? Position vector of point P, right? What is R dash? R dash is a distance of point P from area element, right? Next we are see that R dash vector is a vector from area element to point P, right? And what is R dash cap? R dash cap is a unit vector, right? It is a unit vector. Here we are considering surface charge density, right? So what is sigma? Is the surface charge density. Sigma is known as the surface charge density, right? What is dA? dA is the small area element, right? Area element. It is an area element. What are the charges present on this element? That is dq. We are going to consider dq are the charges present on the small area element. So dq, we are defining over here dq. dq is the charge present on area element. We know the definition of surface charge density, that is, suppose sigma is the surface charge density, definition charge per unit area, right? We want to calculate the charges. See how many charges present on this area element, that is dq. What is the area of this? that is dA. Sigma is constant, so we can calculate the value of dq, and that dq equal to sigma into dA. So we will write dq equal to what? dq equal to sigma into dA, equation number 1. dq is what? Number of charge present on the small area element, right? Okay, see next. So what we defined? dq. dq equal to what we decided? Sigma into dA, first equation, right? Okay, now the next step, that is electric field at point P. Electric field at point P due to the small area element. Small area element will be that will be, we will define by d delta E vector, small electric field at point P due to the area element, right? What is the general formula? We know that the general formula E equal to what? K Q by R square. What is Q? Electric field due to the charges, source charges. So K remains as it is. Q means what? That due to the electric field is present. So what is that? That is dq. Here that is dq. Here r square means what? Distance square. What is distance? We know that that is r dash square. And what is r dash cap? It is a unit vector in the direction of electric field, right? So this is electric field, this is small electric field at point P due to the small area element. But our aim is to find electric field at point P due to the whole surface, right? That's why, so total electric field, for that purpose we are going to add all the electric fields. So adding, so we will write E vector equal to, before that we are going to simplify this equation, right? So simplifying the above equation, before this we will simplify the equation, means what? We will put the value of dq. So q equal to dq equal to sigma into dA divided by r dash square into r dash cap. So this is the dE vector. Now we will put the, for the total electric field. Now total electric field at point P, that will be E vector equal to summation of K sigma dA divided by r dash cap square, into r dash cap. This is your final equation. It is the electric field at point P due to the surface charge distribution, right? So this is your question. This is your topic. You can make the question, find out the electric field due to the surface charge distribution, and the answer of this question you may write like this. Here your answer ends. You just take the screenshot. Okay students, now we are moving towards the next topic, that is electric field due to the volume charge distribution. So we are just erasing the required things. See, surface, instead of surface charge density we will write volume charge. See what I am replacing, you just pay attention. Electric field due to the volume charge distribution. The diagram will change. See the diagram. For that purpose we have to consider a volume. Volume means you can take a sphere, a cube, right? That we can take. See, Suppose we consider over here a one cube. This is a cube, right? So consider this cube is divided into small cubes, right? So consider one of the small cube. Consider one of the small cube, right? This cube is at a r vector is the position. See, r vector is the position vector of small volume element. Instead of area element, we will write volume element. Instead of area element, we will write volume element, right? R vector is the position vector of volume element. R dash is the position vector where we want to calculate the electric field, right? So here in this way we will draw that R dash vector. This distance is known as the R dash, and R dash cap is the unit vector in the direction of electric field. Like this we can draw R dash cap. So R dash vector with the position vector of a point P. R dash distance of point P from the volume element we will write over here, right? See, just erasing the few words, you can prepare a new question, right? See, volume element, we will write over here volume element, right? R dash is a vector from area element. Instead of area, we will write volume element. Volume element at point P. R dash unit vector. Here, instead of surface charge density, we will write volume charge density. Volume charge density denoted by letter rho. Rho. So area element, instead of area element, we will write volume element. Volume element, right? What is volume element? That is dV. Right, dq are the charge present on volume element. Right, dq equal to what? Rho into dA. Rho into dA, right? Writing this. What is the rho? Equal to what? Charge per unit volume. So what are the q? That are the dq. What is V? That is dV. So dq equal to what? Rho into dV. So dq equal to rho into dV. Rho into dV. Next, dq equal to rho into dV. Electric field at point P, due to the small area element, instead of area we will write volume. That is volume. Right? Will be d vector dq r dash, this will be right. Next, instead of dq, what we will write? Rho into dV. So here we will write rho into dV divided by r dash square into r dash cap. So total electric field at point P, that will be E vector equal to K rho into dV r dash square into r cap. This is the end of the question. Again, you just take the screenshot, right? And we will move towards the next topic. Okay, students, see, by preparing only one question, you made a 3 questions. Electric field due to the line charge distribution, due to the surface charge distribution, and due to the volume charge distribution, right? Now we are moving towards the next topic, that is electric flux. This is the new topic and very important topic. There will be a question, state and explain the Gauss law. What I told? The new topic is Gauss law, right? The new topic that we are seeing, the name of the topic is Gauss law. Topic number 1.14. State and explain the Gauss law. The question for 2 marks. State and explain, right? We are giving the heading over here. See the spelling. 1.14 is the topic. GAU, Gauss law, right? New topic that we are going to see, Gauss law, right? The question, state and explain Gauss law. For that purpose, first of all, we will see the statement of the Gauss law. See statement. What is the statement? We will see statement. See, the flux associated with any closed surface. Flux means phi. The flux linked with any closed surface is equal to the charge enclosed by the closed surface to the epsilon 0. See, I am repeating the statement once again. The flux linked with any closed surface is equal to the charge enclosed by the closed surface to the epsilon 0. This is the statement, this is the theoretical statement, and that statement we are going to convert into mathematical form. See how we can write. See, phi equal to summation of charge divided by epsilon 0. Charge enclosed by the, total charge enclosed by the closed surface to the epsilon 0. This is the mathematical statement of Gauss law, right? Also we can write like this, E vector dot ds vector, right? Integration over a closed surface. This is the mathematical statement of Gauss law, right? See, for that purpose now we are going to prove the Gauss law. See, suppose we are having a plus, or suppose we are having a charge q. Around the charge there is a presence of electric field in all directions. As we know that electric field is present in all directions, radially inward or outward. If the charge is positive, the electric field will be radially outward. If the charge will be negative, electric field will be radially inward, right? So suppose at a distance r, means suppose if we take a distance r. So what is the electric field at this point at the r distance due to this charge? Suppose it will be a E. Suppose we are going to consider same distance on the upper side, same distance on the downside, same distance on the right side, left side, and if we join all the particles or the points, all the points having a distance r, so the imaginary surface made, that will be a sphere. In all directions we will consider a points at a distance r. So we will get an imaginary surface that is known as the sphere, and that imaginary surface here is known as the Gaussian surface, right? So we will indicate this is a Gaussian surface. Gaussian surface means what? So the point where electric field will be the same, or all the points that are at the same distance from the charge. We are going to consider one of the small area over here. So A vector will be the area vector, or we can denote that is, suppose by letter ds vector is the area vector of this small area. What is the direction of electric field? That direction of electric field will be, suppose this is the direction of electric field, right? And this is the direction of area vector, right? So using the Gauss law, what we can write, suppose electric flux associated with the small area, that phi equal to d phi is the electric flux associated with the small area, right? So that d phi equal to what? E vector dot ds vector, right? So here E vector and ds vector. What is ds vector? Ds vector is the area vector of the small area element. So this E vector and ds vector are in the same direction. So E ds cos theta. Theta is the angle between E and ds. So here cos theta is 0. So we will write E into ds. This is the flux link with the small area. This is the flux link with the small area. We want to calculate how much flux link with the given sphere. So for that purpose, integrating above equation, or we can take the summation of all the flux link with the small number of smalls area. So total flux, total flux, that is phi equal to, adding this we will write E into ds, right. So electric field is constant, so electric field we take outside. Take the E constant. E is constant. At all points electric field is same because all the points are at the same distance from the charge. So phi equal to E will be outside, summation of the ds. Here if we add all the small area, so you will get E into S. What is S? S is the surface area of the sphere. See, what is S? S is the surface area of the sphere, and that S equal to 4 pi r square, surface area of the sphere. So we are going to put the value of E and S. What is E? E equal to what? E equal to, we will write K Q divided by r square, right. So K Q divided by r square into S equal to what? 4 pi square. So this is the flux. Again, what we know that, what is the value of K? That is 4 pi epsilon 0. 1 divided by 4 pi epsilon 0 is the value of K. This is small q, this is r square. Again 4 pi r square remains as it is, right. See, this 4 pi get cancelled, this r square get cancelled, and flux phi equal to, you can write epsilon q divided by epsilon 0. This is the proof of Gauss law. If there is a question in the examination, so you just write down up to this, right. Gauss law, state and explain the Gauss law. Okay, in the next video we will see some important points regarding the Gauss law.